have a dream that one day
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And ignition and liftoff of Ares 1X, testing concepts for the future of new rocket design.
Welcome to the second lesson on exponents. In this lesson, we will have a more detailed look at simplifying exponential expressions. And we're going to look at 4 standard techniques for doing this. Firstly, simplifying numerical expressions, then simplifying literal expressions, then using common factors, and lastly, manipulating the numerator and denominator. In this example, we have to simplify each of the following expressions, these 4 expressions. Let's look at the first one. So 5 to the 0 is 1. We have a fraction raised to a negative power, so we can invert the fraction and the power becomes positive. So it's 16 over 9 to the positive a half. We can get rid of the 5th root here by raising 32 to the power of 2 over 5. And then we have a decimal which we can write as a fraction. So 0,125 is 125 over 1,000. We are dividing by 1 with 3 zeros because we have 3 digits behind the decimal. And we know that this is equal to an eighth. So we can write 0,125 as an eighth, and it's raised to the power of negative 2/3. So this is equal to 1 plus, now we can use prime factors of 16 and 9. 2 to the 4 gives us 16, and 3 squared gives us 9. This is all raised to the power of a half. Then, using prime factors of 32, it can be written as 2 to the power of 5, and this is all to the 2/5. We can invert an eighth, and the power becomes positive, so it's 8 to the positive 2 over 3. Now we can apply the power here to both the numerator and the denominator. We can multiply 4 by a half to get 2, so it's 2 squared in the numerator. Then 2 times a half is 1, so it's just 3 in the denominator. Multiplying out the powers here, the 5's cancel, and we have 2 squared. And in using prime factors of 8, it's 2 cubed, all to the 2 over 3. 2 squared, of course, is 4, so it's 4 over 3. Then we have minus 4. We can multiply out the powers here, the 3's cancel, so we're left with 2 squared, which is 4. The negative 4 cancels with the positive 4. So we have 1 plus 4 over 3, which is 3 over 3 plus 4 over 3, which gives us 7 over 3. Let's look at the second expression. What's important to note here is that we can't apply the power outside the brackets to the power or the powers inside the brackets across a plus or a minus. We have to simplify inside the brackets. So 2 to the negative 1, we can write as 1 over 2 to the positive 1, or just a half. Then we have 4. This is all to the negative 1. We're going to write this mixed fraction as an improper fraction. So 3 times 1 is 3, plus 1 is 4. So it's 4 over 3, and this is all squared. We add the numbers inside the brackets to get one fraction. So the LCD will be 2. Remember that this is 4 over 1. So 2 into 2 once times the top is 1. 1 into 2 twice times the top times 4 is 8. This is all over, or rather to the negative 1. We can apply the power here to both the numerator and the denominator. So it's 4 squared, which is 16, over 3 squared, which is 9. So here we have 9 over 2 to the negative 1. Now we can invert the fraction and the power becomes positive. So 2 over 9 to the positive 1, or just 2 over 9, plus 16 over 9, and this is 18 over 9, which of course is 2. Let's look at the third expression here. We can get rid of the cube root in the numerator by writing it as 24 to the 2 over 3. We're going to use prime factors of 18. So let's find the prime factors. The smallest number into 18 is 2, and it goes 9 times. Into 9, 3, and it goes thrice. Into 3, 3, and it goes once. So 18 can be written as 2 times 3 squared. We're going to write the square root of 2 as 2 to the 1 over 2, getting rid of the square root. Now we're going to find prime factors of 24. So let's find the prime factors of 24. The smallest number into 24 is 2, and it goes 12 times. Into 12, 2, and it goes 6 times. Into 6, 2, and it goes thrice. Into 3, 3, and it goes once. So 24 can be written as 2 cubed times 3. And this is all to the 2 over 3. Because we have brackets here, we're going to multiply the powers. So it's 2 to the 1 times a half, and 3 to the 2 times a half. 2 times a half is 1, so we have 3 to the 1, or just 3. These factors can cancel. And we're going to use or multiply the powers here where we have brackets. So 2 to the 3 times 2/3. The 3's cancel and we're left with 2. So it's 2 squared. And 1 times 2/3 is 2/3. So it's 3 to the 2/3. Now, 2 squared is 4. Then, where we multiply and the bases are the same, we're going to add the powers. And where we divide with the bases the same, we subtract the powers. So it's going to be 3 to the 2/3 plus 1 minus negative 1/3. So we have 3 to the 2/3 plus 1. A minus, we should have a minus in here. A minus times a minus is a plus, so it's plus 1/3. And we're left with 4 times 3 to the power of 2/3 plus 1/3 is 1, plus 1 is 2. So 4 times 3 squared, and 3 squared is 9. So 4 times 3 squared will give us 36. Coming to the last expression here, it's going to be 3 to the negative 1 minus 2. So where the bases are the same, we subtract the powers, times 2 to the 3 minus negative 2. The 3 to the negative 2, we're going to put into the denominator as 3 to the positive 2, or 3 squared. So minus 1 minus 2 is minus 3. And a minus times a minus is a plus. So we have 3 plus 2, which is 5. Of course, this is 2 over 9. Once again, we're going to put the 3 to the negative 3 in the denominator as 3 to the positive 3. And 2 to the 5 is 32. So it's 32 over 27 plus 2 over 9. And we can write this as one fraction. The LCD is 27. 27 into 27 once times the top is 32. 9 into 27 3 times the numerator. So 3 times 2 is 6. And our final answer then is 38 over 27. Let's look at your answer to the first question here. 7 to the 0, of course, is 1. We can get rid of the cube root by writing it as 8 to the 1 over 3. And then we can take the 2 to the negative 1 into the denominator as 2 to the positive 1, or just 2. Now we can use prime factors of 8. We know that 8 is 2 cubed. One minus 1.5, or 3 over 2, is negative a half. We can multiply the powers here, and the 3's cancel, so we get 2. And then negative a half plus 2 is 1.5, or 3 over 2. Then in number 2, we can get rid of the fourth root by writing it as 81 to the negative 1 over 4. And of course, anything to the power 0 is 1. We can invert the fraction here, and the power becomes positive. So 27 over 8 to the positive 1/3. Now we can use prime factors of 81. We know that 81 is 3 to the 4. And we can use prime factors of 27, which is 3 cubed, and 8, which is 2 cubed. We multiply the powers here, so the 4's cancel, and we get 3 to the negative 1. Now, in the third term in the expression, we can write 3 over 2 all to the 3. So 3 over 2 all to the power of 3, and then all raised to the power of 1/3. Of course, 3 to the negative 1 is a third. We can multiply the powers here, and the 3's cancel, so we have 3 over 2. Now we can write it all as one fraction. We find the LCD, which is 6. This, of course, is over 1. So 3 into 6 twice times 1 is 2. 1 into 6, 6 times 1 is 6. And 2 into 6 thrice times 3 is 9. And our final answer then will be 2 plus 6 plus 9. In other words, 17 over 6. In number 3, we first simplify under the square root. So 5 squared is 25, and 3 squared is 9, so 25 minus 9 is 16. Then, where we multiply here, we add the powers, and where we divide, we subtract the powers. So it's going to be 2 to the power of 5, plus negative 4, and then minus negative 2. Then we write the decimal as a fraction, so it's 25 over 100, which is a quarter. This is all to the negative 2. Of course, the square root of 16 is 4. 5 plus negative 4 is 5 minus 4. Then a minus times a minus is a plus. So it's plus 2 over here. So 5 minus 4 is 1. Plus 2 is 3. So it's 2 cubed. Here we can invert the fraction and the power becomes positive. So it's 4 over 1, or just 4, to the power of positive 2. And of course, we simplify. 4 minus 8 plus 16 is 12. Coming to number 4 here, we can first find prime factors of 12, and 12 can be written as 2 squared times 3. We can get rid of the square root here by writing it as 18 to the 3 over 2. In the denominator, we can get rid of the 6th root here by writing it as 8 to the 1 over 6. And the square root here by writing it as 3 to the 1 over 2. Now we can multiply out the powers here where we have the brackets. So 2 times a half is 1. So we have 2 to the 1, or just 2. And then 3 has a power of 1 that we don't write. So then 1 times a half is a half. Then we can use prime factors for 18. It's going to be 2 times 3 squared. Prime factors of 8 will be 2 cubed. These two factors cancel. So we have 2, and then times. Once again, we can multiply the powers here. So it's 2 to the 3 over 2 times 3 to the 3. The 2's cancel here. Then in the denominator, 3 times a 6th is a half. So we have 2 to the half. We can now add the powers where we multiply and subtract it where we divide. So it's going to be 2 to the 1 plus 3 over 2 minus a half. And 3 cubed is 27. 1 plus 1.5 is 2.5, minus a half is 2. So we have 2 squared times 27. And this is 4 times 27. And 27 times 4 is of course 108. We could do it on a calculator. Let's look at your answer to the last question here. What's important to note is that we can't apply the 2 to the powers inside the brackets across a plus or a minus. So we simplify inside the brackets first. 2 to the negative 1 is a half. 2 to the negative 2 is 1 over 2 squared, or a quarter. And we use prime factors for 8, which is 2 cubed, all to the negative 2 over 3. Now we get the fractions inside the brackets. We write it as one fraction. So the LCD is 4. 2 into 4 twice times 1. 4 into 4 once times 1. This is all squared. We multiply out here. We can multiply the powers. So it's going to be 2 to the negative 2. The 3's cancel. And 2 plus 1 is 3. So we have 3/4, all squared. And we can write this with a positive power as 1 over 2 squared, or 1 over 4. Now we can apply the power to both the numerator and the denominator. So we have 3 squared, which is 9, over 4 squared, which is 16. Then finally, writing everything as one fraction, the LCD is 16. 16 into 16 once times the top. 4 into 16 4 times the top. So our final answer then is 13 over 16. In example 1b, it says, simplify each of the following. So let's look at the first one. We have to apply the power outside the brackets to everything inside the brackets. The 2 has a power of 1 that we don't write. So multiplying the powers, it's 2 to the 1 times 3. And then we multiply the power of x also by 3 to get 3p minus 9. 2 cubed is 8, so we have 8x to the 3p minus 9. Let's look at the second question, or expression. Once again, we have to apply the power to everything inside the brackets. So it's 32 to the 2 over 5. X to the negative 15 times 2/5 is negative 6. Now we can use prime factors of 32. It's 2 to the 5. We can multiply the powers here, and the 5's cancel. So we have 2 squared x to the negative 6. And 2 squared, of course, is 4. We can also take the x to the negative 6 into the denominator as x to the positive 6. Let's look at the third expression. As usual, we first simplify inside the brackets. We can get rid of the cube root by dividing all the powers underneath it by 3. Now, 27 has a power of 1. So we have 27 to the 1 over 3, a to the 6 over 3, so a squared, and b to the 9 over 3, which is b cubed. This is all to the power of negative 2. Now we can multiply the power outside the brackets by each power inside the brackets. So 27 to the negative 2 over 3, a to the negative 4, b to the negative 6. We can now use prime factors of 27, so it's 3 cubed. Then multiplying the powers where we have brackets, we have 3 to the power of 3 times negative 2/3. The 3's cancel, and we're left with negative 2. Now, all the powers here are negative, so we can write it as 1 over, and all the powers become positive. So 1 over 3 squared, a to the 4, b to the 6th, and then finally, 3 squared, of course, is 9. So it's 1 over 9, a to the 4, b to the 6. Let's look at the last expression here. So we have 3 to the 1 plus x. And we're going to use prime factors for 24. So let's do that. The smallest number into 24 is 2. And it goes 12 times, into 12, 2, and it goes 6 times, into 6, 2, and it goes thrice, into 3, 3, and it goes once. So 24 we can write as 2 cubed times 3. So 2 cubed times 3, and this is all to the x plus 2. We now find prime factors of 18. So prime factors of 18. The smallest number into 18 is 2, and it goes 9 times, into 9, 3, and it goes thrice, into 3, 3, and it goes once. So 18 we can write as 2 times 3 squared. And this is all to the x plus 1. Now 4 we can write as 2 squared using prime factors, and it's all to the x. So let's simplify further. Where we have brackets, we can multiply the powers. So it's going to be 2 to the 3x plus 6 times 3 to the x plus 2. Multiplying out the powers here, we get 2 to the x plus 1 times 3 to the 2x plus 2. And here we get 2 to the 2x. We're going to add powers when we multiply and the bases are the same, and subtract the powers where we divide and the bases are the same. Let's first look at the 3's. So it's 3 to the 1 plus x plus 2, then minus 2x plus 2. So we get minus 2x minus 2. Then the powers of 2, we have 2 to the 3x plus 6 minus x minus 1, and then minus 2x. So we see that plus 2 here cancels with minus 2. And we also have x plus x, which is 2x, minus 2x, which is 0. So the x's cancel as well. And we're left with 3 to the 1, or just 3. Then we have 3x minus x is 2x, minus 2x is 0. So once again, the x's cancel here. And we're left with 2 to the 6 minus 1. In other words, 2 to the 5. So this is equal to 3 times 32, which is 96. So let's look at your answer to the first question here. We have a choice as to how we can start. We can either start by multiplying the power outside the brackets by each power inside the brackets, or we can invert everything and the power becomes positive. Let's go with the second option. So it's going to be 1 over 5a cubed b squared all to the positive 2. Now we can multiply the powers. So there's a 1 here associated with a 5. So it's 5 to the 1 times 2. A to the 3 times 2. B to the 2 times 2. And this is equal to 1 over 25 a to the 6, b to the 4. Let's look at your second answer here. We can start by using prime factors for 16. So it's 2 to the 4. Now we can multiply the powers. So 4 times a half is 2. So it's 2 squared. Then 2 times a half is 1. So it's just x. And then y to the negative 3. 2 squared is 4. And we can take y to the negative 3 into the denominator. And the power becomes positive. In number 3, we can start by simplifying inside the brackets first. We can get rid of the square root by dividing all the powers underneath it by 2. So we're going to get 12 to the 1 over 2 p to the 2 over 2, which is p to the 1, or just p, and then q to the 4 over 2, or p, or q squared. This is all to the negative 3. Now we can multiply the power outside the brackets by each power inside the brackets. So it's going to be 12 to the negative 3 over 2, p to the negative 3, q to the negative 6. We can now use prime factors of 12, so it's 2 squared times 3, and then multiplying the powers again. 2 times negative 3 over 2, the 2's cancel, and we're left with 2 to the negative 3. Then 3 to the negative 3 over 2, p to the negative 3, q to the negative 6. All the powers are negative, so we can write it as 1 over, and the powers all become positive. So it's going to be 2 cubed, 3 to the positive 3 over 2, p to the positive 3, q to the positive 6. This is multiplication. So it's 1 over 3, or 2 cubed is 8. There's nothing we can do here. And this is our final answer. Once again, we can start by simplifying inside the brackets in the numerator. We can get rid of the cube root by dividing all the powers underneath it by 3. So it's 8 to the 1 over 3, 8 to the 3 over 3, which is a to the 1, or just a, then b to the 6 over 3, or b squared. This is all to the power of 2. We can also use prime factors for the 4, so it's 2 squared Now we can multiply the powers in the numerator. So it's going to be 8 to the 2 over 3, a squared b to the 4. Now we can use prime factors of 8. So 8 to the 2/3 can be written as 2 cubed to the 2/3. Then multiplying the powers here, the 3's cancel, and we're left with 2 squared. So then in the numerator, we're going to have 2 squared, then a squared b to the 4. These factors cancel, and we're left with b to the 4 divided by b. We're dividing, and the bases are the same, so we can subtract the powers. So it's b to the 4 minus 1, which is b cubed. Let's look at the last of your answers here. So we have 3 to the n minus 1. We can use prime factors of 9. So 9 to the negative 4n. We can write as 3 squared to the negative 4n. And multiplying out the powers, we get 3 to the negative 8n. So 3 to the negative 8n. Then we can use prime factors of 27. So 27 to the n plus 1. We can write as 3 cubed to the n plus 1. And this is 3 to the 3n plus 3 when we multiply the powers. So 3 to the 3n plus 3. In the denominator, we still have 3 to the negative 3n plus 1. Now we can add the powers where we multiply and subtract them where we divide. So 3 to the n minus 1 plus negative 8n. So minus 8n plus 3n plus 3. When we subtract the bottom power, the sign changes over here. So it's plus 3n plus 1. Then adding like terms, we have n minus 8n, which is negative 7n, plus 3n, which is negative 4n, plus 3n, which is negative n. Then we have minus 1 plus 3, which is 2, plus 1, which is 3. We could leave our answer like this, or we could go one step further. We could write it as 3 to the negative n times 3 cubed. 3 cubed, of course, is 27, and we could take the 3 to the negative n into the denominator, and the power becomes positive. In this example, we have to simplify each of these expressions. Now, the difference between these expressions and the ones that we've come across before is that both types are algebraic fractions, but in this type of problem, the terms in either or both of the numerator and denominator are separated by pluses or minuses. We're going to use the law, the exponential law, a to the m plus n is equal to a to the m times a to the n. And we're going to use this law to split up the terms. So let's look at the first one. So then using this exponential law, we can split up 3 to the x plus 1 into 3 to the x times 3 to the 1, or just 3. We can do the same with the second term in the numerator. So we can write it as 3 to the x times 3 to the negative 1. And we can leave the denominator as is. Now we can take out a common factor containing the term in x in the numerator. In this case, we're going to take out 3 to the x. So 3 to the x is a common factor. What's left of the first term will be 3. Then we have 5 left of the second term times 3 to the negative 1. Now 3 to the negative 1 we can write as a third, and this is all over 4 times 3 to the x. Very conveniently, the 3 to the x's cancel. So in the numerator, we have 3 minus 5 times a third. Now, 5 times a third, bearing in mind that 5 is the same as 5 over 1, we multiply the numerators. So 5 times 1 is 5, and 1 times 3 is 3. So it's 5 over 3. And in the denominator, we still have 4 left. We can evaluate the numerator. 3 can be written as 9 over 3. So 9 over 3 minus 5 over 3 is 4 over 3 in the numerator. And in the denominator, we have 4, which is the same as 4 over 1. The last step now is, because we are dividing a fraction by a fraction, we can multiply the numerator by the inverse of the denominator. And the 4's will cancel. So we are left with 1 over 3. Let's look at the second expression. Once again, we're going to use this law to split up terms. So 2 to the 2x minus 1, we're going to write as 2 to the 2x times 2 to the negative 1. We can use prime factors for 4. So we're going to use 4 to the x is the same as 2 squared to the x. And this is the same as 2 to the 2x. So 4 to the x we can write as 2 to the 2x. And in the denominator we have 3 times. Once again, using this law, we can split up the 2 to the 2x plus 1 into 2 to the 2x times 2. Now we can take out a common factor in the numerator again. So it's 2 to the 2x, and in the first term we are left with 2 to the negative 1, which is a half, and then minus 1. 2 to the 2x into 2 to the 2x once. In a denominator we can also multiply 3 by 2 to get 6, and it's times 2 to the 2x. These terms cancel, or factors, and we are left with a half minus 1 in the numerator, which of course is negative a half, and 6 in the denominator, which is the same as 6 over 1. Once again, we can multiply the numerator by the inverse of the denominator. So 1 times 1 is 1, and 2 times 6 is 12. So it's negative 1 over 12. Let's look at the last question here. We need to simplify this expression. (25) to the m we can write as 5 to the 2m. Then, using this law, we can split up 5 to the 2m plus 1 into 5 to the 2m times 5. In a denominator, we have 5 to the 2m plus, and once again we can split up this term into 5 to the 2m times 5 to the negative 1. Now we can take out a common factor in both the numerator and the denominator containing m. So we have 5 to the 2m into 5 to the 2m into 5 to the 2m once, and in the second term we are left with 5. Taking out a common factor of 5 to the 2m in a denominator, it goes into here once, plus, and here we are left with 5 to the negative 1. The 5 to the 2m's cancel, and now we are left with 6 in the numerator and 1 plus a fifth in the denominator. Now 1 plus a fifth, of course, is 1 and a fifth. And writing this as an improper fraction, 5 times 1 is 5, plus 1 is 6. So it's 6 over 5. So we have 6 divided by 6 over 5, which is the same as 6 times 5 over 6. Here the 6's cancel, and we're left with 5 as the final answer. Let's look at your answers to this question. In the first question, we can split up the first term in the numerator into 2 to the x times 2. Then in the second term, we can split up 2 to the x minus 1 into 2 to the x times 2 to the negative 1. This is all over 3 times 2 to the x. Now we can take out a common factor of 2 to the x in the numerator. So 2 to the x. What's left in the first term is 2, then minus 3 times 2 to the negative 1, which is a half. These terms cancel, or these factors cancel. And now we're left with, in the numerator, we're left with 2 minus 3 times a half. So 2 minus 3 times a half is 3 over 2, or 1.5. And 2 minus 1.5, of course, is a half. So it's a half over 3. Now, 3 is actually 3 over 1. So we can simplify this by multiplying the numerator by the inverse of the denominator, by 1 over 3. And now multiplying the numerators is 1, and 2 times 3 is 6 in the denominators. Let's look at number 2. We can first write 9 to the x as 3 to the 2x. And we can split up the second term in the numerator. We can write it as 3 to the 2x times 3 to the 1. In the denominator, we can split up 3 to the 2x minus 1 and write it as 3 to the 2x times 3 to the negative 1. We can now take out a common factor of 3 to the 2x in the numerator, and we're left with 1 minus 3. And we still have 2 times 3 to the 2x times 3 to the negative 1 in the denominator. These factors can cancel out. Then in the numerator, we are left with negative 2. This is all over 2 to the times 3 to the negative 1. The 2's cancel here. We're left with negative 1 divided by 3 to the negative 1. Now, 3 to the negative 1 we can write as 1 over 3. So we can multiply the numerator by the inverse of the denominator. So negative 1 times 3 over 1. And of course, this is just negative 3. Coming to number 3, (49) to the x we can write as 7 to the 2x. And then we can split up the 7 to the 2x minus 1 into 7 to the 2x times 7 to the negative 1. Then we have 7 to the 2x in the denominator, plus, and once again splitting up the 7 to the 2x plus 1 into 7 to the 2x times 7 to the 1, or just 7. Now we can take out a common factor in both the numerator and the denominator as 7 to the 2x. So it's 1 minus 3 times a 7th is 3 over 7. And in taking out a 7 to the 2x as a common factor in the denominator, it's 1 plus 7. These factors cancel again. Now, 1 minus 3 over 7 is the same as 7 over 7 minus 3 over 7, which is 4 over 7, and 1 plus 7 is 8. This, of course, is the same as 8 over 1. So then multiplying the numerator by the inverse of the denominator, by 1 over 8. Multiplying the numerators will give us 4 times 1, which is 4. And multiplying the denominators gives us 7 times 8, which is 56. And of course, we can divide by 2 in both the numerator and the denominator. And it's going to be, in fact, we can divide by 4. So 4 into itself once, and into 56 14 times. We could, of course, have cancelled 4 into 8 here to give 2, and that will give us 1 over 14 as well. Let's look at the last expression. (25 to the a plus 1) we can write as 5 squared all to the a plus 1. Then we can split up this term in the denominator into 5 to the 2a times 5 to the negative 3. And we still have plus 5 to the 2a. In a numerator, we have brackets, so we can multiply the powers. So 2 times a plus 1 is 2a plus 2. We can also take out a common factor of 5 to the 2a in the denominator, and we're left with 5 to the negative 3 plus 5 to the 2a into 5 to the 2a once. Now we can split up the term in the numerator into 5 to the 2a times 5 squared. And we still have 5 to the 2a into 5 to the negative 3, which is 1 over 125. And we see that these factors cancel. So we're left with 5 squared in the numerator, which of course is 25. Then 1 over 125 plus 1 is 1, and 1 over 125. Writing this as an improper fraction, 1 to 5 times 1 is 1 to 5, plus 1 is 1 to 6. So in the denominator, we have 126 over 125. Now we can multiply the numerator by the inverse of the denominator. And of course, this is over 1. So then multiplying the numerators, so we have 25 times 125, which is 3,125. So 3,125, and in 1 times 126 is 126. Here's an important additional example on the common factor type of exponential expression. We have to evaluate this expression, and we're going to take out a common factor in the numerator. So the question now is, what is the common factor between 3 to the 2018 and 3 to the 2016? It's going to be the number with a smaller power, in this case 2016. So we take out 3 to the power of 2016. Now, what is left of our first term? We basically use law 1, and we take 2018 minus 2016. So it's going to be 3 to the power of 2018 minus 2016, which is 3 squared, or 3 to the power 2. Note that when we multiply back in, we're going to add the powers, and we're going to get back to 2018. Then 3 to the power of 2016 into 3 to the power of 2016, of course, is ones. And in the denominator, we still have 3 to the power of 2017. Now, here we are dividing, and the bases are the same, so we can subtract the powers. So it's 3 to the power of 2016 less 2017. Then in the brackets we have 3 squared, which is 9, plus 1, which is 10. So this is going to be 3 to the power of negative 1 when we subtract these two numbers, and this is times 10. And then 3 to the negative 1, of course, is a third. So it's a third times 10. And we know that this is equal to 10 over 3. Let's look at your answer to this question. We have to evaluate this expression. And we're going to use common factors. So in the numerator, we're going to take out a common factor. And it's going to be 3 to the power of 2013. In other words, a number with a smaller power. So 3 to the power of 2013. What's left of the first term, 2015 less 2013, will be 2. So we're left with 3 squared. Note that when we multiply back in, we're going to get back to 3,215. And then, of course, plus 1. In a denominator, we're going to write 9 as 3 squared. So we're going to have 9 to the power of 1006, which we can write as 3 squared to the power of 1006. And in multiplying the powers, we get 2012. So in a denominator, we have 3 to the power of 2012. Now, here we are dividing, and the bases are the same, so we can subtract the powers. And in the brackets, we are left with 10. So, 2013 minus 2012 is 1. So we're left with 3 to the 1, or just 3. And in times 10 will give us 30. Example 1D deals with an important type of exponential expression where we have to manipulate the numerator and denominator. This type of problem is easy to recognize. We have an algebraic fraction. We have pluses and minuses between the terms in the fraction, and we also have negative powers. We start by using the exponential law. A to the negative m equals 1 over a to the positive m, in order to get rid of the negative powers in the expression. So let's do that. So in the numerator, x to the minus 1 we can write as 1 over x, and y to the minus 1 we can write as 1 over y. Then in the denominator, we can take the x to the negative 2 into the denominator of this term, so we can write it as y over x squared. And in the second term in the denominator, we can take the y to the negative 2 into the denominator of this term, and we can write it as x over y squared. So that's our first step. Now we get both the numerator and the denominator as one fraction. So in the numerator, the LCD is xy. So xy, x into xy, y remains, times 1 is y. Y into xy, x remains, times 1 is x. We also write the denominator as one fraction. So the LCD here in the denominator is x squared, y squared. X squared into x squared, y squared remains, times y is y cubed. Then y squared into x squared remains, times x will give us x cubed. Now we have a fraction over a fraction, so we multiply the numerator by the inverse of the denominator. So multiplied by x squared, y squared, all over y cubed plus x cubed. We can simplify this stage, x into here and y into here. So xy into x squared, y squared goes xy times. We can write the fraction in a more compact way. We have a 1 left here. So it's going to be y plus x over 1 multiplied by xy over y cubed plus x cubed. We have a sum of cubes here. So we need to know how to factorize a sum of cubes. So remember, it's a, if you have a cubed plus b cubed, we have two sets of brackets. We find the cube root of the first term, which is a. We use this sign, in other words a plus. The cube root of the second term is b. Then in the second set of brackets, a times a squared will give us a cubed. We use the opposite sign that we have in this set of brackets, so a minus, and it's a product of these two terms, so ab. And then plus b times plus b squared will give us b cubed, or plus b cubed. So we can factorize this sum of cubes. So it's y plus x over 1 multiplied by xy and in applying this factorization to the sum of cubes, we're going to get y plus x into y squared minus xy plus x squared. Now we see that these two factors cancel in the whole expression, and we are left with xy. So xy over y squared minus xy plus x squared. Let's look at your answer to this question. So, using the law, a to the negative m is 1 over a to the m. We can get rid of the negative powers, and in a numerator, in the first term, we can take the b to the negative 1 into the denominator of this term. So it's going to be a over b, then minus b over a. Here we are taking the a to the negative 2 into the denominator of the second term in the numerator. We do the same in the denominator of the expression. So b to the negative 1 is 1 over b, and a to the negative 1 is 1 over a. Now we get the numerator as well as the denominator as one fraction by finding the LCD in each case. In the numerator, the LCD of these two terms will be AB. Then b into AB, a remains, times a is a squared. A into AB, b remains, times b is b squared. Then writing the denominator also as one fraction. The LCD here is AB. So AB, b into AB, a remains, times 1 is a. And a into AB, b remains, times 1 is b. So we end up with a fraction divided by a fraction. So we can multiply the numerator by the inverse of the denominator. So it's going to be a squared minus b squared all over ab times ab over a minus b. Immediately, these terms cancel. So we are left with a squared minus b squared over 1. Now, this is a difference of squares. So it's a minus b when we factorize times a plus b. So this is all over 1. And then multiplied by 1 over a minus b. These factors in the expression cancel. And then we are left with a plus b.